Okay, so how is everyone today?
Great.
Great. Okay, so there's an exam in 7 days and 6 hours. That's exciting. So, in particular, that means that it's not in this room, right? And it's not during lecture. Probably tonight or tomorrow, there will be a grade in the grade book. Grade, scare quote grade, which is the room that you'll be in. So not all of you will be in the same room because all of college algebra is taking the exam simultaneously in a multitude of rooms. So there'll be a grade. So watch for that message, and then find where that room is in advance. Good. So to business. So we had ended with inequalities, absolute value inequalities. So here's an example of one. How about 5w plus 3 divided by 4 is greater or equal to 6. Okay, and then the request is that we should solve this. So again, taking the strategy that we used from last time, if you just sort of cover this up and just ask, what is it that you could put in there so that the resulting inequality would be true?
6 or greater.
Yeah, so you could put 6 in there, or you could put 6.1, that'd work. You could put 6 million. What else could you put in there? Negative 6 would work too, right? Because if I'm covering up, I can't quite, my finger's not quite big enough, but if I was covering up a negative 6, then the absolute value would flip it to a 6, and the inequality would be true. And similarly, if I was covering up a negative 8, the absolute value would flip it to a positive 8, and the inequality would be true. All right. So what I'm saying is that if what's in there is big enough, if what's in there is 6 or bigger, then we're good to go. Similarly, if it's small enough, if it's negative 6 or smaller, then we're good to go. So viewing that as a picture, what is the characteristic shape of absolute value? A V, right? So I'm going to draw such a V. Now, all the stuff that's inside of that absolute value, it's a little bit complicated. So I'm not going to say that this is absolute value of W. Rather, I'll just say that this is like absolute value of Z or something like that. And then if we were to plot y as 6, that would be a horizontal line above the origin. And then, so what I want you to observe is that in this view, I changed it. I'm representing all that stuff that is in there as a z, and the inequality is reading like absolute z greater or equal to 6. And I split it into 2 parts. And I'm asking, well, suppose we plot y as absolute z in red, and suppose we plot y as 6 in green. Then we did an inequality last time, and we kind of rendered that in English, that inequality symbol. So what this is saying, we want the red bit, the absolute value bit, to be above or touching the green bit. Above or touching. Okay. So let's see if we can sort of see that from the picture. So like, how about right there? So that particular x value that I'm pointing at with the pencil. Notice that the red point is below the green point. Is that the kind of point we're looking for? Where the red is below the green? Now we want it to be the other way, right? We want red to be above or touching the green. So are they touching anywhere? Yeah. Red and green are touching at that x value, or z value, I guess, and that one also. That's where they touch. Now, where is red above or touching? So how about like right there? So do you see that that red point is above that green point? So that's one of the points that we want, right there. Similarly, that one, but not this kind, because red is below green there. So can you see everywhere that red is above green? So red is touching green there and there. That's touching. And then red is above green on that part and on that part. Okay, so this one is 6 and this one is -6. All right. So when we were doing this last time, it was in fact exactly the opposite. And last time, because the inequality was turned the other way around, it was all the stuff between the 6's. That was the answer. Now on this one, because we turned the inequality around, now it's all the stuff outside of the 6's. Well, so that's going to be some interval, and that's another interval. And if you were to compute the union of these two intervals, would that union simplify? It would not. What must be true about intervals so that their union will simplify? They have to overlap. So this is an infinite interval, and that's another one, but they have no overlap, and as a result, the union won't simplify them. Okay, so because of that, algebraically, the problem splits into two parts, like we said before. You either have to be small enough, so it needs to be the case that 5w plus 3 over 4 is less or equal to -6. So small enough, which is to say being on the left piece, or you have to be big enough. Being on the right piece. And so this is sort of in contrast to that previous kind, the previous kind that we solved, where we could basically write something like A less or equal B less or equal C. So many times students look at this and say, oh, I don't like that. That's more writing, and I don't like doing that. Well, I don't either. You know. And I promise you, if there was some shorter way for you to do it, then I'd show you. Not just for you, but for me, because you know, I have to look at what you write. So there's no shorter way to do this. So let's solve. I'll multiply both sides by 4. For both inequalities. I'll subtract 3. And then divide by 5. Okay, so then that divided by 5 would be -5, and then I'd have 2 more, so 0.4. And for that one, that would be 4 and 0.2. All right. So now, writing these in interval notation, how can we write this answer in interval notation? How do we write that bit? Very good. Uh-huh.
Negative 5.4 to 4.2.
Okay, so now we're going off the rails.
1.2 to
Okay, so this one, yeah. So that one by itself is that. And this one by itself is this. And then the or, when you're writing it in interval notation, becomes union. So now it's going to be that one or that one. So what I want you to see is that it's the left piece or the right piece, just like in the picture. The left piece or the right piece. So can you see it? Now, you might, all these questions are exactly the same. Can you simplify this union? You cannot. Do these two intervals overlap? No. Is there a shorter way to algebraically accomplish this task? No. All those questions are the same question. And the answer to all of them is no. Okay, whereas in the other case, if you look at notes from Friday, the inequality was turned around. The intervals that we were interested in was just the one. Now, because there's just one interval, that means that there's no unions to simplify, and the algebra is simpler to deal with. Okay. Any questions about this? Yes?
So if we have a question like this like on the midterm, do we have to draw out a graph like that?
No.
So that's just for us to understand it better?
Yes.
Okay.
Other questions? All right. Good. So we're talking about inequalities, and just like equations, many students get to this class, and then they see the instructor write something down like that, okay, and then ask, is this an equation? And then most students want to say, no, no, but yes, it's an equation. It's an equation because all that an equation is it's two expressions, one that you refer to as the left-hand side, the other the right-hand side, and an equal in the middle. Now, the thing is, if you feel compelled to say, no, this is not an equation, what you really mean is that when you evaluate this equation, what's its value? False. So is this an equation? Yes. What's its value? False. All right. So here's another example. So how about 13 less than 14? So is this an inequality? Yes. What's its value? True. Here's another one. 20 less or equal 18. Is this an inequality? Yes. What's its value? False. Okay, so just like we talked about with equations, that you can always add or subtract the same number from both sides, and the truth will be preserved. The logical value will be preserved, which is to say that here's an equation that's false. If you add the same number to both sides, the resulting equation is still going to be false. Won't change it. Now, concerning equations, you can also multiply both sides by the same number. So almost any number. What's the one that's not permitted? Zero, right? You can't multiply or divide both sides by 0 because that can modify the truth. Inequalities have exactly the same restriction. You can't multiply both sides of an inequality by 0, but you can add the same number to both sides. But even inequalities are slightly more interesting because for equations you can multiply both sides by, for example, -5. That's fine. You can divide both sides by -5. That's fine. For an inequality, it is okay to multiply both sides by -5, but what must happen? Yeah, the direction of the inequality has to change. Okay, so just as a very simple example, just to make sure you've seen it in action at least once, we could do, how about 3 minus 4x is greater or equal to, I don't know, 8. So, one way we could do this is we could say, okay, I will subtract 3 from both sides to get negative 4x greater or equal to 5. And then, you know, if we wanted to solve for x, then what can we do? We could divide both sides by negative 4. All right. Now, is it permitted to divide both sides by negative 4? Is that an okay thing? It is. The new left-hand side will be x. The new right-hand side will be 5 over negative 4. But, and here's the tricky business, is what? Right. Now this inequality is going the other direction. Okay, and if that seems like sort of a strange rule to remember, here's another way to take this exact inequality. You could say negative 4x greater than or equal to 5. All I did was copy it. And now instead of doing this division, which maybe you think is not really legitimate, maybe, I'll add 4x to both sides. So that the new left-hand side is 0, and the new right-hand side is 5 plus 4x. And then I'll subtract 5 from both sides, so that the new left-hand side is negative 5, and the new right-hand side is 4x. And now, instead of dividing by negative 4, I'll divide by just a regular old 4. And then the inequality is negative 5 over 4 greater than or equal to x. So are those the same? Yeah, they're the same. But, you know, this way is just more convenient. Okay, any questions about this? All right. So now what we're going to do is we're going to talk about one of the most important things that you're going to learn in this class, especially if you're going to end up going to calculus. So if you have any plans at all going eventually taking a calculus class, this is a very important thing. Also, it's really tedious. There's a lot of bookkeeping required, and so I'm like prepping you emotionally for that, letting you know that it's coming. Okay, so in order to sort of make the case that we really need something that's careful, and it's worth paying the price, even if the price of correctly answering the exercise is some tedium. Here's an example. So I'm going to solve an exercise. I'm going to solve the following. I'm going to solve x minus 3 over x plus 4 is less than 2. But do note that this is going to be incorrect. So this whole page is just going to be wrong. Okay, and so I'm going to solve it. I'm going to solve it in the way that most students try to solve this. If well, any student who's not here, this is how they're probably going to solve it if they do anything. So all right, I want to solve for x. Good. So the first thing I'm going to do is I'm going to multiply both sides by x plus 4 because I need to get rid of that fraction. All right. So then that means that the new left-hand side would look like x plus 4 multiplied by x minus 3 over x plus 4 like that, and then less than 2 multiplied by x plus 4. So what was the point of multiplying by x plus 4, by the way?
Cancel the bottom.
Yeah, that cancellation, right? So the new left-hand side would be x minus 3, and the new right-hand side would be 2x plus 8. And then now I'll subtract x from both sides so that it's negative 3 is less than, what am I trying to say? Less than x plus 8. So I subtracted x from both sides, and now I'll subtract 8 from both sides and get negative 11 less than x like that. So then so you know, x has to be bigger than negative 11. So as in interval notation, it would look like this. So negative 11 to infinity. And as a plot, it would look like this. All right. This is wrong. It's not even close to correct. So what went wrong? Sorry?
You cancel out the vertical
I don't know what you mean. Cancel it out?
at the top when you multiply x by 4.
This?
Yeah, or do you remove that from the equation?
Okay.
Aren't you supposed to multiply by algebra?
So let's think. So in the first place, is this inequality defined at every point? Is it defined for every value of x? No, right? So for example, this inequality has no value and is not defined at negative 4. It's not false, it's not true, it's just not defined, right? Because you can't divide by 0. And so, you know, we didn't even talk about that. So that's just omitted. Further, let's consider. How about let's do some checking. Let's check maybe at x is 100. Because is 100 in there? Yeah, it's in there. So if I plug in 100, then the inequality would read 100 minus 3 divided by 100 plus 4 less than 2. Well, let's think about this for a moment. That's 97, right? And that's 104. So is that less than 2? It is, right? Because even in fact, that's less than 1. So that's good. That's good. What about, how about negative 10? Is that in there? Yeah? So let's check it at negative 10. So that'd be negative 10 minus 3 over negative 10 plus 4 less than 2. So that'd be negative 13 over negative 6 less than 2. And then the negatives cancel, right? The negatives cancel. And it would be 13 over 6 less than 2. Is that right?
Yeah.
That's not right. So notice that, you know, this one, we expected this inequality to be true, and it is true. That's good. We expected this inequality to be true, but it's false. Okay. And, you know, what if we plug in, I won't take the time to do it, but we expect the inequality to be false over here. But if you plug in a point over here, in fact, the inequality is going to be true. Stuff went really bad. So what happened? Where does the mistake come? Which step did I make the mistake on? My experience tells me that that no student's able to point out where it occurs, historically speaking. I'd love it to be proven wrong. Where did it happen? In fact, the very first step is the wrong step. The very first one. Wrong. The reason why it's wrong is the following: is that in the very first step we're saying let's multiply both sides by x plus 4. Now the point of that is so that we can make that cancellation. But here's the deal: is it permitted for you to multiply both sides of an inequality by a number? Yeah. And if that number happens to be positive, then the direction of the inequality stays. But if it's negative, the direction of the inequality reverses, right? Well, How about x plus 4? What is the sign of x plus 4? Is it negative or is it positive? It depends on the value of x, doesn't it? The only value of x that's not permitted is negative 4. So is it permitted for x to be 100? Yeah? And when x is 100, x plus 4 is positive. Is it permitted for x to be negative 10? It is. And when x is negative 10, x plus 4 is negative. So when we multiplied both sides of the inequality by x plus 4, and we didn't reverse the direction of the inequality, what we're saying is that I'm just going to assume, for no good reason, that x plus 4 is positive all the time. So can you see where it broke? Where it broke down? Yes?
So would you have two inequalities then?
So now I'm going to do. I'm going to show you how to do it properly. Okay, but do you see that there's something going going bad here? All right, so this is just that won't work. All right. So same exercise as before. What was it? The request is to solve x minus 3 divided by x plus 4 less than 2. But now we're going to do this correctly. So the way we're going to do it is with something called a sine charge. So it has the sine chart method has several steps. The first step is to find the natural domain. Of the inequality. So what's the natural domain of the left-hand side?
X is not equal to negative 4.
Right. Every x is permitted except negative 4. And then what's the natural domain of the right-hand side? All, right? So the only problem is at negative 4. All right? Now that doesn't mean the inequality is true for everything except negative 4. Rather, it's just defined for all of those. So now we're going to do some algebraic steps. And I'm going to call this the 0 and factor step. So specifically what we're going to do is I'm going to take that inequality and I'm going to move all terms to one side of the inequality. Okay, so I'll move the 2 to the left-hand side so that it looks like this. X minus 3 over x plus 4 subtract 2 less than 0. All right, so that 0 is why this step is called the 0 and factor step. Now, concerning the left-hand side, we're gonna simplify it as much as possible and factor it. All right, so then we want to find a common denominator. So this term is over x plus 4, and what's this term over? A 1, right? So then I'll write that this is x minus 3 over x plus 4, and then subtract, and I want that 2 to be over an x plus 4 so that it's the same as the other one. But what's the cost of putting an x plus 4 right there? Also putting it on the top. All right. So then x minus 3 over x plus 4, subtract 2x plus 8 over x plus 4 less than 0. Yes, it is, but then my eraser, I just couldn't. It's got this thing on it. Let me just tear it off here. Better. All right. Okay, so now we want to perform the subtraction. So now I'm going to make a mistake. So x minus 3 subtract 2x plus 8 over x plus 4 less than 0. So what mistake did I make? Right. It's all of that numerator minus all of that numerator, which is to say that these should really be in parentheses. Before I wrote the parentheses around the 2x plus 8, we were adding 8, but really you're subtracting 8. Okay, so then carrying that out in the numerator, I see negative x, and then negative 3 minus 8 is negative 11 over x plus 4, less than 0. And then I'll factor the negative out and get what in the numerator? X plus 11, and then x plus 4, like this. All right. Now, we did a bunch of algebraic steps. And I have a question. In this sequence of algebraic steps that's on the page there, how many times did we do something to both sides of the inequality? Exactly once. And it was, we subtracted 2 from both sides, right? So that one of the sides would be 0. Now, is it always safe to add or subtract the same number from both sides? It is. And that is the only thing that we did to both sides. That's it. So there's no way that we could have broken it. You see what I mean? There's no way it could have gotten messed up, because we just didn't do anything that was unsafe. All right. Now what we're going to do is we're going to solve the corresponding equation. Now, what this exercise is about solving an inequality. And we've gotten to here. And now I'm going to take this, and I'm going to write exactly that, except equation. So, negative x plus 11 over x plus 4 equal 0. Okay, exact same thing as down here, except I wrote equal now. Okay, so now I'm going to multiply both sides by x plus 4. Now, wait a second. Didn't I, on the previous page, just chastise myself and all of us for doing that? Multiplying both sides by x plus 4? Didn't we just say how unsafe that was? Yeah. But what? But now it's an equation. Do we need to worry about the direction of the equation reversing? No, that's not even a thing. Right? So, the x plus 4 cancels, and we have negative x plus 11 is equal to 0, like that. We could, multiply both sides by negative 1 and get x plus 11 is 0, I suppose. And then what's the solution? X is negative 11. Ah, okay. So now, this method is named after this step. So now we're going to make the sine chart. And so what we're going to do is we're going to plot a number line. Plot a number line. And we're going to plot all the breaks in the natural domain from 1 and all of the solutions to the corresponding equation from 3. So we're going to plot that and that. So we're going to plot this one and that one. Oh, whoop. Okay, so I did it. I wanted to do it, and then I forgot, and then I did it on accident, but good. So this is not right. What's not right about this? Right. The, negative 11 is the smaller one, right? So negative 4. I wrote it again. Negative 11. Negative 4. All right. So now, in each piece, we've cut the number line into 3 pieces. We want to select a point. So what's a point that's to the left of negative 11? So what's a point? Negative 12. All right. And what's a point that's in between these two? Negative 6 is what I heard. How about a point that's in here? 0. All right. So now what we're going to do is we're going to take this right here, this thing, and we're going to evaluate it at all of those points. So here's a negative, so that negative just stays there. So negative, and then for this, if we plug in negative 12, will that factor be negative or positive if we plug in negative 12? Be negative, right? So negative. And then if we plug in negative 12 into that factor, what will the result be? Negative or positive? It'll be negative, right? So negative 12 plus 4 is something negative. Similarly, if we plug in negative 6, so that negative is just hanging out there, and then plugging in negative 6 into that, we get something positive, and then plugging negative 6 into that, we get something negative. Okay, wait. Yeah, and then plugging in 0, we have that negative just hanging out, and then plugging 0 into that one, what do you get? Something positive, right? And then for this one, something positive. And so now, for each one of those patterns, the question is what is the overall sign? So what is it if you have something negative, negative, and then negative again? It's overall negative, right? Because they cancel out in pairs. So this is negative. How about in this region? Positive, because those two negatives cancel. And how about in this region? Negative. So why do you think this thing's called a sine charge? Because it's a chart full of sines. Yeah, that's it. That's the reason. So we either want all of the negative regions or we want all of the positive regions. So which ones do we want? And why? We want the negative regions. Why? Because we're negative people? Yeah. Correct. No. We want the negative regions because, have a look at the inequality. What we're saying is we want to know when this thing is less than 0. So we want the ones that are labeled negative. If this inequality was pointing the other way, then we'd want the positive regions, right? Okay, so then the answer is negative infinity to negative 11, union, negative 4 to infinity. Very good. Okay, so we'll do more of these next time, but now we have a quiz.